Welcome to Math TV with Professor V. It is Wednesday, March 1st. Yay, happy March. 2023, here is your integral of the day. We have antiderivative of 1 over square root of 25x squared minus 121 dx. And then notice off to the side here, letting you know that x is greater than 11 over 5. What's the point of saying that? That way you know the quantity underneath the radical will never be negative. Therefore, the integrand is well defined. Okay? We won't have any domain errors. Good. So you don't really do anything with this. You just go, whew, this is never going to give us any problems. So how to begin? Well, it's trig sub time. I actually did this integral yesterday in my office hours with the student, and it worked out so nicely. I thought, let me make it for all my lovely people on YouTube. You have to identify which of the 3 trig subs is appropriate. Since we have the variable quantity squared minus a constant, it's time to bust out secant. And then you have to be careful because we have a constant in front of the variable, and that needs to be taken into consideration. So we're going to choose x carefully. X has to be 11 over 5 secant theta. And then that means dx will be 11 over 5 secant theta tan theta d theta. And now we're ready to switch and rewrite our integral in terms of theta. Do it all at once. Don't leave half of it still in terms of x and then the other half in terms of theta. All right, so in the numerator, instead of dx, right, all of this is dx. So that's what's going to go upstairs. 11 over 5 secant theta tan theta d theta. Then in the denominator, we have square root. I won't skip any steps just in case this is tricky for you, like it was for my student. So then we've got 25 x squared. That's going to be 11 over 5 secant theta squared minus 121. Good? Yes, I love it. Now let's start rolling. So immediately, I want you to take this constant outside. Put it here so it's not bothering us anymore. Good. Then we have secant theta, tan theta, d theta over. Let's multiply out what's underneath the radical. We have 25 times. Make sure you're careful here. You have to square the numerator and denominator of the constant. So it's going to become 121 over 25 secant squared theta minus 121. So notice we chose everything so carefully so that these 25s would cancel out now. Beautiful. So what do we have here? 11 over 5 integral of secant theta, tangent theta, d theta over square root. Now notice I can factor out 121 from both terms here under the radical, and we have secant squared theta minus 1. Very good. Now, if you'll recall, secant squared theta minus 1 is equal to tangent squared theta. So in the denominator, now we have 11 over 5 sitting outside, secant theta, tan theta, d theta upstairs, and square root of 121 tan squared theta. Now be careful. Square root of 121 tan squared theta technically is 11 times absolute value of tangent theta. But if you'll go back to the video where I introduced the idea of doing trig sub, we restrict the angle theta. That way we know that tangent theta will always be positive. So we don't have to worry about keeping the absolute value bars in our integral. That's a relief. So you can just write 11 tan theta down here with a clean conscience. But always keep in mind, when you have the square root of x squared, it's equal to the absolute value of x, okay? Don't be a sloppy calculus student. No. All right, from here, it's so satisfying. Look, bam, bam. You can cancel out those tangents. Anything else you notice you can cancel? Why, yes, the 11 be gone. Okay, is that it? Yeah, I wanted to get rid of the 5, but no, we can't. We can't do that. Okay, so all we have right now is 1/5 integral secant theta d theta What's the antiderivative of secant theta? That's one you need to just have memorized. If you didn't, you can review it right now. So 1/5 ln absolute value, secant theta plus tan theta plus c. I show how to do it in the video lecture for 7.2 on trig integrals that's linked in the description box. The way you come up with the antiderivative for secant theta is not very intuitive, okay, to get this. So that's why I always just encourage my students to memorize it. All right, now, no, you can't box the answer just yet because we have to go back and rewrite everything in terms of x. And how to do that? Well, you go back to the original substitution that you made. We let x equal 11/5 secant theta. So that's how we're going to get back to x land. So x was 11/5 secant theta. Isolate the trig function, meaning 5/11x is secant theta. I'm fine leaving it like that. If you're not comfortable, you can rewrite it as cosine theta equals 11/5x. That's fine. Whatever you need to do to draw this lovely triangle, this theta triangle. Cosine is adjacent over hypotenuse. And then we need this missing side here. So using the Pythagorean theorem, it's going to be square root of 25x squared minus 121. Okay? And notice that was the original radical expression we saw in the integral to begin with, which is pretty normal. Great. So from here, watch this. We've got 1/5 natural log absolute value. Instead of secant theta, what am I going to write? 5x/11. That's what secant theta equals. Oh, okay. That was easy enough. Plus, now for tangent theta, we're going to use the triangle. So tangent is ratio of opposite over adjacent. So that will be square root 25x squared minus 121 over 11. And then we have plus c. Now, you could stop here, but most of the time when you check an answer key or whatever, they'll simplify it further. And let me show you how. So notice that we can combine both terms inside the argument of the logarithm because they have denominator 11. So I could write this as absolute value 5x plus square root 25x squared minus 121 all over 11 plus c. And then I want you to recall one of your log properties. So when you have, say, natural log of a divided by b, you can rewrite that as natural log of a minus natural log of b, right? Good. So that's essentially what we have going on here. This is a, this is b. So you can rewrite this as 1/5 ln absolute value 5x plus rad, that's ugly, let's fix it, 25x squared minus 121 minus 1/5 ln absolute value of 11 is just 11 plus c. And then now we wouldn't stop there. Why not? Well, 1/5 ln of 11, that's just a number, right? There's no variables in this term right here. So I can just lump it in with the plus c and be done with it, except now I have to call my constant something else. So usually, here's the deal. You could call the new constant d or something like that, k, but we like to end with plus c, as you know, typically in math. So you go, oh no, this is c, where, and then we got to go back and change the other one to something else. I don't know. Let's call it k. Let's call it k. You usually do this as an afterthought, and then you pretend like, no, I knew all along I was going to do this, right? Where c equals k minus 1/5 ln of 11. Ba-boom. And then this is just the cleanest little antiderivative you ever did see. So classy, so succinct. That's like mwah, putting the creme de la creme on your final answer, you know? Okay. So anyways, I hope you enjoyed that integral of the day. I know I pointed out a lot of little tiny nuances, but that separates a good student from an excellent student. Strive for excellence. You're capable of it. Give the video a thumbs up if you enjoyed it. Leave me a comment below. What is everyone up to today? Believe it or not, I'm going back to ballet. I had to be begged to go back, and then now I actually am enjoying it quite a bit. I danced for 16 years growing up, and then I've taken just as long of a hiatus, actually. So it's interesting to get back into it now at this point in my life, but I'm enjoying it. So hope everyone's having a good start to March. It's a fresh month. Subscribe to my channel if you haven't already. Please share this video with whoever you think would enjoy it. Your family, your classmates, your neighbors, your mailman, massage therapist, nail tech, I don't know. You never know who would enjoy a good integral. Bring it up at the dinner table next time there's a lull in the conversation. You can also catch me on TikTok and Instagram at MathTV with Professor V. Take care, you guys. Bye.